Hello guys, in this video we are going to see the first part of integration by parts. The idea is to get used to this technique of integration and apply it in several examples, okay? What are we going to need? Okay, we need to recall the product rule for differentiation and some familiarity with calculus and some integrals. Okay, let's see, let's start. The idea of the integration by parts comes from the product, the derivative of the product. You can obtain this formula directly by just calculating the derivative of a product and rearrange the terms. So it's not difficult to obtain. The key point of this technique is that it's used to integrate product of functions. Be careful. The integral of a product is not the product of the integrals, okay? One thing that you are commonly mistaken is that, okay, I give you the integral of x e to the x. Then you integrate x, you integrate e to the x, and then multiply the solution. No, that's not true. So sad, okay? But it's not true. The problem is that when we have the product of functions, we need to apply different techniques. One of the important techniques that we are going to know to understand is integration by parts. So the idea is the following. You will have two functions, product of two functions, and then you are going to identify one of the functions with u, this letter, and the other function with dv. The function you decide to be u will we will calculate its derivative, becoming differential of u. And the function you decide to be differential of b is the function you will need to integrate. Be careful, and then it becomes b, here and here. The idea of this process is that the new integral you are going to apply here should be easier. If you find a more complicated integral, please stop and review the method, okay? The idea, this method at least transforms something that it's more or less difficult in something easier. Again, if you find something that is not easier, stop and review the problem from the beginning, okay? Come on, let's see an example. X e to the x. I have two functions. One function is x and the other function is e to the x. Then you need to decide which one is going to be u and which one is going to be differential of b. Important thing, if you call u x, then the differential, the derivative is going to be 1. So it simplifies, disappears, something gets easier. And if you call dv e to the x, the integral is e to the x, is the same. E to the x is the easiest function to calculate its derivative or integral. Okay? If you decide to do it in a different way, if you decide that u it's e to the x and dv is x, okay, the derivative of e to the x is e to the x remains the same. But the integral of x is going to be x squared. Be careful in this moment. You are increasing the degree of the x. No, that's not correct. It's not the way you are going to obtain something easier to calculate. So we are going to keep this identification. Okay, u is going to be x, dv is going to be e to the x, the derivative of x is 1, the integral of e to the x is e to the x. And then I apply the formula. The formula is u times b, so x times e to the x, that I write it here, minus the integral of b e to the x times dx. The integral of x is differential of x. I just told you before that it is 1, but it's 1 times differential of x. Okay, so guys, this integral that I obtained here, it's easier. So I can continue the process. So the integral of e to the x is e to the x, and I just finish. Because this part that appears in the formula is already integrated. You don't need to do anything else with this part. So, piece of cake, okay? So you have a function, you have an example of how to calculate this integration by parts method. Come on, another one, x sine of x. Again, we are going to identify, or we are going to call u this function x, and dv is going to be sine of x. The function I decided that is u is going to be differentiated. So the derivative of x, differential of x. And the one that I call dv sine of x is the one I'm going to integrate. The integral of sine of x is negative cosine. And now I apply the formula. Remember, this is x times b, so x times minus cosine of x. That is written here, minus x cosine of x, minus the integral of b du, so minus cosine of x dx. This integral is easier again because the integral of cosine is sine. Oh, and what happened with the two negatives in here? Negative, negative is positive, the integral of cosine is sine. So I got the solution, okay? It's an easy way to integrate this function. Come on, another one. What happens if I have x times cosine of x? Same process. I identify u as x, the derivative is going to be 1 differential of x. Cosine of x is differential of b, so b is the integral of cosine, that is sine. Then I apply the formula u times b, x times sine of x, and written here, minus b times differential of u. So it's the integral of sine of x, differential of x. Which is the integral? Which is the integral of sine of x? Negative cosine of x. But I had another negative here, so negative is positive. Okay, so I obtained this result. Another example. X times the logarithm of x. Again, be careful. In this example is applied here because it's important how to decide which function is going to be u and which function is going to be differential of b. In this case, if you just call x here, u is going to be x, differential of b is going to be logarithm of x. The problem is that you need to integrate logarithm of x and you don't know which is this integral. Okay, maybe you know and then you are safe, but I don't know. Okay, and not only this, in this problem, I know what is by the way, I know what is the integral of logarithm of x because it's all using the same method, but this is just for another day. The idea is that if you think about yourself, if you think which is the integral of logarithm, okay, it's going to be complicated. So in this way, if we call u logarithm of x and dvx, the derivative of logarithm of x, you know, is 1 over x, and the integral of x is x squared divided by 2. I hope that integrals are already known, because we are mixing derivatives and integrals, okay? Be careful with that. So, applying the formula of integration by parts, I got x squared divided by 2 times logarithm of x minus v times du. Oh, that means x squared divided by 2 times 1 over x. Okay, be careful, that is easy to integrate. X squared simplifies with x, 1/2 can be taken outside, and the only integral is x. And you know that the integral of x is x squared divided by 2. The problem is that I had 1/2 outside, so 1/2 is 1 divided by 4. I hope you really catch the idea, and the last simplification is easy for you. But you know, you now know different examples in which you can apply integration by parts. Okay, guys, what have we seen in this video? Integration by parts for simple functions, okay? Simple products of functions. This method can be applied in more functions, but we will see this in different videos. I hope you find this helpful, and thank you for your attention.